Hi, everyone. This is Professor Lucien, and this is the recording for Chapter 11, Fire Safety. This will be for Monday. We're not going to be meeting because I'm going to be in a virtual board meeting, and then on Wednesday, we have the student presentation. I suppose I could bring it up. We got the student presentation, and then we're going to do a fire extinguisher simulator if we can get it to work. I guess the other class had some issues. So one more thing before we get going. We do have a semester project. I brought it up several times. I just finished it this past weekend. So I would like you guys to work on this and get it done over Thanksgiving because a lot of you will be going home or whatever. But let's take a really quick look. This is the first time I've done it. I really updated what the previous instructors used. So here's the basic idea. I want to see how you can apply, portions of the semester, what we learned in the real world. So these are the chapters that I selected were probably most relevant, though there may be some carryover from others. I want you to inspect for tip over hazards. This is either where you live or your parents' house or your uncle's house or, whatever, wherever you go. It should only take like an hour to finish it all. I want you to inspect cleaning chemicals, home improvement materials, and automotive. So that's more of the, under the kitchen sink or in the bathroom. Home improvement automotive, that's like the garage or the shed, or maybe if they have a downstairs workroom or whatever. Just inspect it to see what they have. Are they stored? Are they leaking? Things like that. Inspect the food stores. So look in the refrigerator. Is it clean? Is it organized? And then I want you to observe how whoever you're inspecting, how they handle post-meal food. So prepared food. Are they following, that 2 hour and a 4 hour mark? And you can look that stuff up. I do want you to look a few things up to verify what you're doing. Next is either your vehicle or your parents' vehicle. Look in the glove box. Are all the records current? And what I mean by that is their registration, their insurance. Is that all in there? Do they keep vehicular maintenance records, and are they current? That's another thing too. Next, I want you to choose a piece of recreational equipment. In that chapter, we had trampolines, we had ATVs, boats. There was so much, all kinds of stuff. I want you to find something of yours. I want you to look at the sort of the manufacturer when it was made, its model, and then go on the CPSC website and see if there's any recalls for that type of product. It doesn't have to particularly be yours, but the product. If you had to know if it was yours, then you would need that information from the sticker, and I want you to find that. Report it. Take a picture. That's fine. I want you to inspect for fire extinguishers and carbon dioxide detectors. If they let you, test them, see if they work, see if they're interconnected or individual. I want you to, and this is more you and either your roommates or you or your parents, kind of consider what are your emergency response plans when it comes to medical emergency, when it comes to evacuation, when it comes to shelter in place. And then finally, what sort of resources do you have? Do you have a first aid kit? Do you have a backup generator? What are you going to do if there is a disaster and you don't have internet, cellular, or power? Strongly encourage you to involve other people, parents, siblings, roommates, extended family, whoever. It'll make this go quicker and it might be more enjoyable for you. And then just let me know who it is. You don't have to give me their name, just who they are. All right, so here are the 10 things you guys need to comment on. So 2 for safety at home, partial here, recreational and fire safety, food safety, transportation safety, recreational safety, fire, emergency preparedness, which is next week. So I will cover this in class, but I wanted to just bring it up. And I don't have a form of how I want it to look. It's scored out of 100 points, 10 per item. Presentation does count. I really would like it if you guys could provide pictures, other comments, let me know who participated. Break it down into sub-items, so there should be 10 sub-items, each one of these. Refer to the chapter, things like that. So yeah, I'm kind of excited about it. It's something you can do just over break, involve other people, brother, sister, cousin, whatever. Go through and try to answer the stuff and then write it up. I think that's kind of cool. All right. Now, Fire safety chapter. So I think that Dr. Buckman did a very, very good job. I really like this chapter. It's almost designed for breaking things down, easy to pick out things for quiz, stuff like that. So I think she did an excellent job. We'll get into the National Fire Protection Association here in a little bit, but they are the group that writes and publishes consensus standards. Now, you'll hear people say, "Oh, that's the law." It's only required by law if another compliance or regulatory agency adopts it. So there are some NFPA standards that have been adopted by, say, OSHA. So now companies have to do it. But NFPA is the sort of the top of the line, the experts when it comes to fire. Let's see, what else? Okay, so they have some really good, she refers to some really good case studies, because it's usually the case studies that generate the regulations, especially after they do the investigation. And one thing she points out here, and this is something that's come up whenever I've had speakers come into my classes, my safety classes from insurance, they talk about authority having jurisdiction. They are who is designated that after a fire disaster occurs, they do the investigation, the origin and cause of it. And sometimes what they'll do is, their report will then be used to generate changes in local or state laws based on what they found. Purpose of the fire, what happened, why it happened, what can be done to prevent it from happening again. Also, their report is used for insurance reasons. That's why my insurance friends will always talk about it. I want you to know this, though. Authority having jurisdiction. When you're in class, they just go they call it AHJ. They go AHJs. They're the ones who do the investigation. And so do you guys know what that means now? If you have any relatives who work in firefighting, whether volunteer or full-time, ask them about that. Actually, that's one of the quiz questions, you guys. So who does the investigation? Authority having jurisdiction, AHJs. All right. Now we're off and running, right? All right. So the chapter talks about the Triangle Shirtwaist Fire of 1911. This was a disaster. It was horrible. And there was a lot of other things going on at the time. There were 146 fatalities. Horrible. People were jumping out of windows down to the street just to try to escape. It's what the owners did. They locked the doors because they didn't want the workers taking home extra fabric. So they locked the doors, and then there's a fire, and then they couldn't get out. It's happened more than once. But the positive thing that came out of this horrible, horrible event in 1911 is it gave birth to the NFPA, National Fire Protection Association, gave birth to the American Society of Safety Professionals, though they weren't called these things originally, and then also gave birth to the National Safety Council. So this one event generated a lot of good, even though it's horrible. And they do have a memorial in New York. If I ever get back there, I'm going to go check it out. But yeah, I've got a video to show you here in a little bit. Here's a case study about the MGM Grand Hotel and Casino fire. Let's see. Wow. With all these rooms and all these guests, only 85 people died out of all that. That's still horrible. Approximately 700 people, including fire, were injured. That's a lot of injuries. The idea is, can you detect it early, suppress it possibly, and if not, have an alarm system that guides people out safely? Okay, and she gives a couple other things here too. We're going to watch a video on the Station nightclub. I remember this. Great White was playing, and pyrotechnics were used in this little bar, if you will, and it ignited, and a lot of people died. How many? Killing 492? Really? Oh, wait, no. That was something else. Killing 100, injuring 230, yeah. One of the deadliest nightclub fires. Ghost Ship Warehouse, I'm not really familiar with this one. It looks like what I'm seeing here is there was fires initiated by suspected electrical problems that can also cause. Before we get to the tetrahedron, there are some videos I want to watch with you real quickly. And I did post
Saturday,
these.
March 25th, 1911. 4:40 p.m. to be exact, nearly quitting time at the Triangle Shirtwaist Factory in New York's Greenwich Village, where 500 workers, mostly young Italian and Jewish women and girls, got ready to collect their pay and go home. Someone dropped a match or a cigarette, and within minutes, the factory, which occupied the top 3 floors of a 10-story building, became an inferno. Fire ladders, which reached only 6 floors, were useless. The fire escape collapsed under the weight of desperate workers trying to escape. One of the doors, it would be reported, was locked. Onlookers out for a weekend stroll in nearby Washington Square Park watched in horror as women leapt to their deaths from upper-story windows, some crashing through the firemen's nets, others hitting the sidewalk with a sickening thud. It's almost a mirror of what happened in 9/11.
In some ways, it was the horror.
So
of the
I'll let
fire.
you guys watch that. I highly recommend. I mean, there's an entire PBS Frontline series documentary on it. This is the 100-year, I think the 100-year anniversary. Yeah. So it happened on March something. I should know this. Okay, don't get mad at me, you guys. I'm sorry. But I do have these right here. And this is just the remembering of it, but it was in March. The next one is the nightclub. This is kind of tough to watch. You can see the pyrotechnics in the background. Everybody's having a good time. And they've now initiated the fire. You can see it. It's small. The guy with the camera's getting out. "30 seconds after ignition, there's finally an alarm that goes off. So I think the cameraman came out a different door than the main door, because here's the main door. People got stuck. They pushed, people fell, and the people became the barrier. That's why so many people died. Okay, so
On February 20th, 2003.
that was 2003. So you can watch that one too. Horrible. There was another camera person there too, and they showed that there are multiple exits to this bar or this venue, but people, we tend to be creatures of habit, and when we come in one door, we expect to exit that door unless guided or instructed to do so. So under this basic disaster, what happened is alarms went off. People were going to go to the front door, where they came out and they just ignored the other exit doors, which they had, and the doors were open, but there's nobody coming out those. Everybody went to the front door. So for everybody listening, wherever you are and there's like an alarm to get out, don't rush to the front door. Try to find an alternative exit. You should be able to look up and see the sign, exit. Take as many people as you can with you to save some lives. All right. There are other disasters that have happened too, and I just want to kind of show them. This one happened in 2020. This is a warehouse in Beirut, Lebanon.
There are troubling new allegations tonight about that deadly port explosion in Beirut. Sources have told the Guardian newspaper that prior to the blast, dozens of bags of fireworks were being stored in the same warehouse as that stockpile of ammonium nitrate, which acts as an accelerant in a fire. In video from the day of the blast, you can see white flashes, what appear to be fireworks, going off before the massive explosion. former port worker told the Guardian newspaper he warned for years it was a disaster waiting to happen and says nothing was done.
It's just incredible, isn't it? It's like special effects almost, you know? It's just amazing, crazy, scary. So this was ammonium nitrate, and somehow the fireworks were set off, spread fire, ammonium nitrate accelerated, and caused that huge explosion. Here's one in West Texas. This was a few years ago.
10 years ago tonight, at this very hour, a tragedy was unfolding in a central Texas town just 120 miles north of Austin.
A deadly explosion erupted at a seed and fertilizer storage facility in the town of West, just north of Waco. Here's KVU's Bob Buckaloo with tonight's backstory.
It was just another business in a small Texas town, West Fertilizer Company, serving farmers near Waco since 1962. On a warm spring night in 2013, the building caught fire. Volunteer firefighters fought the flames for about 20 minutes. Then the worst happened. The explosion of more than 30 tons of ammonium nitrate fertilizer captured on a cell phone camera by a driver passing by. And in this moment, 12 firefighters and 3 people who lived near the plant died. The blast injured nearly 300 people and destroyed 2 schools, a nursing home, an apartment complex, and many homes. The explosive fertilizer had been stored in the building where the fire started. But how did the fire start? 3 years after the explosion and a lengthy investigation, there was a stunning announcement from the Federal Bureau of Alcohol, Tobacco, and Firearms.
The fire has been ruled as incendiary. This means this fire was a criminal act.
The ATF has not revealed what led to its conclusion, and to this day, no one has been arrested. Years after the explosion, there has been little change in regulations for businesses that store ammonium nitrate, despite the urging of the U.S. Chemical Safety Board, a federal agency. Among its recommendations, installing non-flammable storage bins and water sprinklers in facilities that handle the chemical.
Robert Louis Snughouse.
This week,
another thing you can do to make it safer to store this stuff is to store it in smaller containers or shacks, but you space them out. So it's a standalone. You lower the chance of there being ignition sources. If something was to burn or ignite, it'd be a smaller quantity in like a shack or a storage shed. That's what they typically do with gunpowder, is they store them in little sheds in smaller quantities and separate it out. So if something was to go wrong, it'd be a smaller amount and there'd be less likely to be damaged. And of course, it's less likely that they could ignite. And you know what? We also had something happen similar to Whitewater. Now, this was propane, and this was a worker who made some bad choices to release it, but then it ignited.
Also getting a first-hand look now at the destruction caused by a propane tank explosion in Rock County. This happened about 3 o'clock this afternoon at Cooperative Plus on Highway 59. That is in Lima Township, just a few miles west of Whitewater. A neighbor captured one of the explosions on his cell phone. Look at that. It happened when an employee was filling 3,500 gallons of propane into his truck from a holding tank. Now, luckily, no one was hurt, but flames did quickly spread to a large building on the property. Highway 59 is open again, and crews have already left the scene. Those who live nearby were shocked something like this could happen.
Get out of here. You know, it's, I was just hoping to know.
So I remember when that happened because I had a student in my class who was a volunteer firefighter. He got pulled out of class. He got a call. He's like, I got to go. Told us about it the next day that a manhole cover was thrown a mile away. Big explosion. All right. We'll get back to this one in a little bit. So back to the chapter now, fire science. So what is fire? It is a chemical reaction. We call it a rapid oxygen reduction reaction. It's a chemical reaction that typically results in heat, light, and smoke. Fire can be represented as the tetrahedron. So I want you to know the tetrahedron. It's pretty basic, though. You need oxygen. You need heat. You need fuel. You need a chemical reaction. The heat is typically the ignition source. Fuel is usually a carbon-based fuel that burns, although you can burn metals too. But we tend to think of more like the typical fuel. Oxygen is in our environment, but you can suffocate a fire by reducing the oxygen. And then the chemical reaction is the oxygen redox. Now there are fire suppression chemicals out there that what they do is they actually interrupt this reaction, and that's how it firefights. It's a little bit more expensive, and so they use it only in certain applications. And the certain application I'm thinking of is computer rooms. And what are those called? Where they've got all the memory things. You know, if you were to shoot water in there, you destroy all the electrical equipment. Server room. There you go. So what it does is it usually sends out either like a powdered substance or a gaseous, and that floods the room and stops the fire reaction. So sometimes they call it the fire triangle, but it is the tetrahedron because of the chemical reaction. Here are the stages. So there's ignition stage. At that point, you could use a fire extinguisher to put it out, control it. The growth stage, in which it really, really grows, gives off a lot more heat. It's spreading. Fully developed is when, there's significant damage, and then the burnout stage, it's basically dropped. A friend of mine who is the fire chief in Jefferson has said that when you see the ladders go up, it's over. They're just trying to control it from spreading to other areas, but the building that's on fire is a complete loss. So I want you to know the tetrahedron: oxygen, fuel, chemical reaction, and heat or ignition source. Here are the different classifications, and you don't have to memorize these, but I want you to kind of understand them if it's posed to you. First, there's Class A. These are combustible materials. This is the prototypical. Next is fueled by flammable or combustible liquids or petroleum products. So, the typical things like a solvent. Class C is electrical fires or energized by electrical fires. So usually a short or an arc or a spark will set it off. So your standard fire extinguisher is an ABC fire extinguisher. So that is designed for Class A, Class B, and Class C fires. Next is Class D, a little bit different. So this is combustible metals, and they're alloys. So aluminum, lithium, magnesium. So the complaint right now is that the lithium batteries of EV cars, if it starts fire, it's super impossible to put out. Water barely does anything. It's because it burns differently. You need something different than your typical water extinguisher. And the last one, and one I want you to make, special note of, is the Class K fire. K stands for kitchen. So when you're, things involving cooking fats, oils, greases, animal or vegetables, whether it's animal, vegetable, oil, or fat, these things float on water, and so trying to use water to extinguish a Class K will just make it worse. It'll just spread it. So that's another thing I want you to know for the quiz. In addition to what are the elements of the fire tetrahedron, is what is a K fire, and its fires involving cooking fats, oils, and greases. Okay, that's for the quiz. Common causes of fire. So I put this in sort of as a hint. So, residential fires have the following causes. So 50% of them are cooking in the kitchen. That's, just whether burning food and it spreads or burning with oils, the K class, all these things, 50% of them in the kitchen. I want you to make note of that because I put it in as as sort of a hint in, and actually, no, that is a quiz question. Primary cause of fires in residential buildings is cooking. Now realize when you read through here, it'll talk about primary cause of death. They're not saying that in this one. This one is the cause of fires that have been reported. Okay? So cooking with oils, what you really need to do is cover it or use a powder to put it out. Or I think you could also use a surfactant, because all you really need to do is squelch its access to oxygen, and it'll put it out. That's what happens when you cover it. And that's when you put something on that kind of covers it too. Just don't try to pick it up and bring it to the sink, okay? Don't try to throw water on it. Just bad idea. Better yet, don't cook at such high temperatures. And if you're going to cook with an oil or a grease, try to do without flames. Try to keep it covered so it doesn't spit. Here's a few cooking tips. You can read these. These are pretty standard. It's just, some people cook just at too high of temperatures. Never add water to a grease fire. Use a B, C, or K type. So you can get a K type fire extinguisher. That's the type you should have in the kitchen. That could be a good thing for your project to see. If they're using A, B, C, well, it probably will work, but it'd be better to have a K or to have something else that could just cover up or suffocate a fire. So, okay. So yeah, that's cool. I do have something to show you, and that is, because, Thanksgiving's coming up, if you're going to be frying a turkey, you've got to do it outside, off of your deck, away from the house. Because if you overflow the hot oil, it can catch fire, and it happens every year, you guys. So, I've always wanted to do it. I'm too scared. I'm actually too scared to do it. All right. Heating equipment. It's a leading cause of home fire deaths. Heating equipment. So this could be anything from people having like the open heating coil and a blanket getting too close to it. But from the months of December, January, February, it is almost half of the home heating fires occur during this time, and heating equipment is a big issue there. That's also a quiz question. Why do almost half of home fires occur during the winter months? Improper use or failure of heating equipment is the correct answer. Okay? Hopefully you guys are listening to this. Electrical fires are another issue. And this is when this is another question. Under what conditions typically lead to or left unchecked can lead to electrical fires? And you're basically overloading a line, and it gives off heat, and it melts the protective coating on the wiring, and then now it's exposed, and now it can arc and spark, and it can cause fires. And it can happen in walls, things behind things. It can happen with extension cords, with your multi-outlet things. There's a lot of things that can cause overloading on electrical equipment and then not trip a switch or a fuse. So it's something to look out for. Properly designed and installed electrical systems are the key, but then don't overuse those multi-outlets or extension cords. They say on them exactly what they're used for, and sometimes people violate that. So any equipment that's not audiovisual, so a computer, a TV, a radio, those can be plugged into multi-outlets. Those can do just fine with extension cords. It's things like refrigerators, microwave ovens, any sort of like equipment you'd use with a motor or a compressor. These things have higher amp draws and can heat up a line. Okay. Let's see here. Yeah, she says a little bit about smoking, a little about season risk. Grilling, yeah, I mean, as long as you're doing it, outdoors and being safe, it should be okay. It should always be attended, for sure. Don't store propane tanks indoors. Store them outside, because if there's a small leak and it fills a small space, if it ignites, it's going to explode, just like you saw that video near Whitewater. Fireworks are obviously dangerous. Thank goodness we really only use them once a year. They really shouldn't be done anywhere near buildings, and it should be under direct supervision. You got to be careful with this stuff. It's better to shoot these things off over water or a marsh. So winter holidays are also an issue. I mean, it's wintertime, there's heat, you're putting up all kinds of lights, you're putting up other garbage, and then there's wrapping paper, and that can cause a problem. So Christmas trees, especially if they dry out, can be a fire danger. I've got a picture here that compares a two sides. So we have a watered tree that they've already tried to start it on fire. They're 5 seconds in. We've got a dry one over here. They haven't started it yet. So keep watching the watered one. I'm not really seeing much. I see a little bit of a flash of a flame behind it. And there is smoke. You can see the smoke. Okay, they just started the dry one. And look how fast that is. It's been going for under 20 seconds. They just hit 20 seconds and look at it. And still the watered one is smoldering, but this is already out of control. You couldn't fight this. I mean, here's the other thing too. What type of lights and decorations are you using? Your LCD, is it LCD? Yeah, LCD lights don't give off much heat. They don't require much power, so there's not a lot of power running through them. It's a much safer option. But I know everybody's kind of, reminiscent of the old time light bulbs and stuff like that. You just got to be really careful, If it gives off heat, it has a chance of, damaging something or possibly starting a fire. I should have asked. No, I'm not going to ask about that for the assignment, but just be aware, you guys. That stuff goes up pretty fast. Let's see. What did that say? Barn fires. Yeah, that can be another issue. Hoarding risks. Sure, if you got more combustibles around, it can be a problem. One thing we look for as safety people when we walk through a plant, particularly warehouses, is where are you storing your extra pallets? And if you have the plastic pallets or totes, those are even worse because plastic is essentially solidified gasoline. So if there's a fire and it starts melting those, it's going to be almost impossible to stop and it's going to spread. At least the wood, you have a chance. But if you're just stacking it, it's like a perfect fire formation because it's spaced out, it's dry, air can get in as it needs to. So yeah. So there's a few more questions here too. Let's talk a little bit about fire detection. So you'll see sometimes, especially in rentals, they'll just stick up a lone smoke detector. And it's basically just battery operated. In homes today, they should have battery backup, but be hardwired and be interconnected. So if one goes off, all goes off. And that is something that I want you to check out for your project, is just to see, are they interconnected? I mean, and can you test them? I know, people only worry about changing the batteries. No, you should still test those things at least twice a year. So one of the questions I have is, what is the typical lifespan of a smoke detector? Because we're supposed to change the batteries every 6 months. They say during the changing from daylight savings time. But I just saw a commercial. Menards has a deal on a smoke detector, carbon monoxide detector, that should last 10 years. But what Dr. Buckman says here is detectors typically have a 10-year span. I, myself, actually purchased a box of smoke detectors, smoke and carbon monoxide detectors. And what I do is I change them out like every couple of years. They're expensive if you buy more of them. It's super easy to switch out. Just go out there, disconnect the wire, reconnect it in. It's a certain fitting. Super easy to do. But you guys should be checking these things. These are the things that are going to save your life and the people you live with. Carbon monoxide, very important too, required in Wisconsin to have these. And carbon monoxide is incomplete combustion of a carbon fuel. And it's deadly to humans. So because our blood prefers it over oxygen. Way to go, blood. Detection and alert are very, very important. And I want you to remember the 10-year lifespan, because that's a quiz question. 10-year lifespan for typical detector. Okay, controlling fires. So in the home, we're typically going to be using a fire extinguisher. But you need to know that water can be used, but only used for Class A fires. Dry chemical is for ABCs. That's the typical fire extinguisher right there. The dry powder. Carbon dioxide can be used for B or Cs. Wet chemical containing alkaline mixtures, that's for K. And then the copper powder, sodium chloride, removes the oxygen or heat element, can be used for Class D fires. So you kind of see the breakdown. I think that's really interesting. I would have a Class K here, the wet chemical containing alkaline mixtures in the kitchen. Metals, that's pretty rare, but a carbon dioxide, I might have that, near where I'm doing like my woodwork or cutting metals. And my dry chemical I would have in several places too. One on each floor at least, especially where you're going to be doing sort of cutting, heating, burning, things like that. Have them. It's a good idea. Another quiz question, you guys. How to use a fire extinguisher. Now, we're going to do this in class, but I want you to remember the PASS acronym. I did bring it up in class the other day. PASS. Pull the pin, aim low, squeeze the lever slowly and evenly, sweep the nozzle from side to side. PASS. Pull, aim, squeeze, sweep. Remember that. That's on the quiz. I said, what's the acronym you need to remember that indicates the steps for using an operating a fire extinguisher? PASS. P-A-S-S. Please remember that. And then we're going to practice it in class. It's kind of fun. All right. So the last few things it talks about here is coming up with an escape plan. So you want to prevent fires. You kind of, we have a basic idea of what could cause them. Let's try to, through design and rules on how we use things, try to prevent it from happening. Okay, but we're never perfect there. So therefore we want to find a way to detect and alert. And that's, we talked about that, detectors. Lastly, we want to, if we can't suppress, and we just talked about an exhaust or fire putting out rules, you need to plan for escaping or responding through exiting. That's the word I was thinking of. So what's interesting is here, NFPA and the Fire Marshals Association devise a program called Operation EDITH, E-D-I-T-H, exit drills in the home. This is another quiz question. It says, to protect yourself and others from fires, planning and preparedness are essential. The NFPA Fire Marshal Association of North America devised a program called Operation EDITH to help people prepare. What is the foundation of EDITH? It is exiting or escaping planning and drills. So a plan of what to do and then practice that bad boy, okay? I would like you to ask, for the project, I want you to ask your family about this. If you don't plan for something, you're basically planning to fail. So it would be good to discuss this with family. In the dorms, do they talk about this stuff? Whenever I go to a hotel, I look at the maps. I see where my exit routes are. Even when I just go to places, I always kind of take a peek at, do they have sprinkler heads? Is it sprinklered? What color is it? Because I know what temperature would set it off. What sort of detection they have. What are the exits? I just do that naturally. But for people who are not in the know, what are they going to do? They're going to run for the front door, right? Versus what is the proper thing to do? Oh, I should have shown that clip of Dwight when he lit the fire. He's like, today, smoking is going to save lives. Dwight Schruteism. So make an escape plan. Communicate the plan. Know at least 2 ways out. Practice the drill. Close doors behind you when you leave. Well, unless there's people coming behind you. But if there's no one else there, close doors as you go. College students, you need to think about this stuff. Your dorms are probably equipped with sprinklers. I wonder how often they test them, whether they're dry lines or wet lines. It matters. Depending on how much water's in the system, who knows? And then it talks here about, wherever you go to big events that are crowded, there's a reason why the AHJs will enforce when there's big gatherings and they try to prevent overcrowding, for the very fact that if there is a fire, are the exits adequate to allow people to get out quickly and safely? It's true. We've had too many instances. Finally, we kind of wrap up with NFPA and many local fire have information on how to plan for fires and other emergencies, OSHA's regulations. So you can look things up, and there is resources out there for you. And that is basically the last quiz question, which is which organizations develop standards to guide proper planning, design, program, and response to fires. That is the National Fire Protection Association, NFPA. There's a lot of information there, but you have to buy their standards. It's just like ANSI. But you can look up information, and then here are the key takeaways. The last thing I wanted to point out that I didn't think was covered was dust explosions. And I just want to show you a quick, this is in Indiana, but this looks like a grain mill really close to where I live. You see the grain is starting to come out? well, grain dust, wood dust, metal dust, flour dust, creamer dust. That stuff, at a certain concentration, if given an ignition source, can not only burn but explode. You're going to see it here.
There goes.
See, you wouldn't think that would happen. But dust explosions, what they basically do is the little flecks that are combustible, it's like a chain reaction. One burns another one, burns another one. And then each time one little one burns, it expands rapidly. So you have that happen within like less than a second. You have this percussion or concussion wave that comes out. It'll damage other equipment. And that's what could cause adjacent leaks, damage, hurt people, or cause secondary fires or tertiary fires. So that's basically everything, you guys. This went a little bit longer than I wanted, but we got to see some pretty cool videos, I think. Look forward to seeing you guys on Wednesday. Thank you.